So today we are going to discuss about the sterilization methods and its design findings. So overview of the presentation follows as sterilization, various sterilization techniques and the methods of sterilization, kinetics of thermal sterilization, and followed by tutorial problems. Okay. So we know that sterilization means it is the process of eliminating or killing the unwanted microorganisms or unwanted transmissible agents. Okay, for example, some unwanted bacteria, virus, fungi from food materials, process equipments, biological culture media, and surgical instruments. Okay. So these are the various sterilization techniques are available today. Those are broadly classified into physical sterilization and chemical sterilization. Physical sterilizations are further classified into thermal sterilization, radiation, and filtration. Chemical sterilizations are further classified into liquid sterilization and gaseous sterilizations. Those are examples are given here. So the sterilizing material is a thermally sensitive. Then you can go for the chemical sterilization. And physical sterilization like radiation and filtration. The sterilization material or sterilization media is thermally resistance. Then you can go for the thermal sterilization like dry heat sterilization, moist heat sterilization. Okay. If it is thermally sensitive, that media is thermally sensitive means we can go for the UV X-ray radiation or electromagnetic radiation, or go for the filtration, depth filters or membrane filters. Okay. So generally, this chemical, liquid and gaseous sterilizations are highly preferred, and the sterilization of the uh, working benches, that environments, laboratory environments, and the environment which is associated with the reactors, reacting space, and the environment, the operators are utilizing the plant sources. So there are two types of sterilization, batch sterilization and continuous sterilization. Generally, these batch sterilizations are highly used for solid media, and continuous sterilizations are highly preferred for the liquid media. In this batch sterilization, the temperature will be around 121 degrees centigrade. Longer heating up and cooling down time is required in the case of batch sterilization, whereas continuous sterilization, the temperature will be more than 121 degrees centigrade. It deals with high temperature and high pressure. Sometimes there is a chances of some contamination occurred in the continuous sterilization. Okay. Here you can see the pictorial representation of the batch sterilization and the continuous sterilization. In the case of the batch sterilization, steam will be entered into the jacket of the reactor. Here, jacket of the reactor, and steam leaves from the exit of the reactor, so that the media will be heated inside the reactor. The media will be heated and sterilized inside the reactor. In the case of the continuous sterilization, media and steam both are passing through a tubular flow reactor. Means steam is injected with the media. Steam is always traveled along with the media into a tubular flow reactor, and which is released from the vacuum flash chamber, like a sterilized medium, like a sterilized medium. Okay. Here, sterilization time will be very less in the case of continuous sterilization. If you want to produce the large amount of biological products like antibiotics, vaccines, want to produce bulk amount of products within a less span of time, then generally these continuous sterilizations are highly preferred. If you want to prefer the uh, high sterilization, most efficient sterilization with less quantity of the biological products, then we can go for the batch sterilization. Before going to kinetics of thermal sterilization, let me ask two questions. Which sterilization method is highly preferred for the solid media, and which sterilization is highly preferred for the liquid media? Okay.